Good morning, student. My name is Dr. Tanuj Kumar from the Department of Mathematics, SRM Institute of Science and Technology, Delhi NCR campus, Ghaziabad. So, in the today lecture, student, we will discuss about the unit mathematical logic in the discrete mathematics for engineers. Okay. So, in this unit, basically, we will cover the following topics: preposition and the logical operators and their truth tables. Then we will discuss about the tautology, contradiction, and the contingency. Further, we will discuss about the equivalence and the implication compound statements or the prepositions. Okay. So, as per the Bloom taxonomy, this is the course CLO 3 solving problem of mathematics L1, L2, L3. So what is a preposition, student? A preposition is a declarative sentence which is either true or false but not both is called a preposition or a sentence statement. Sentences which are exclamatory, interrogative and the imperative in nature are not the preposition. So generally lowercase letter are used to denote the preposition or the statement. For example, suppose P is a preposition which is denoted by the statement x square plus y square is equal to a square. So it is basically a circle of radius a, okay, which is I denote by a sentence, and this sentence is called a preposition. Okay. So generally we will denote the preposition by the small letter P, Q and R, etc. And sometimes we can use the capital letter for to denote the preposition or the statement. Okay. So these are some example of the preposition. For example, Ghaziabad is a city. Yes, this is a true sentence. So this is a statement, or you will say that it is a preposition. Further, you know, 2 plus 2 is equal to 4. This is a mathematical sentence. And in this sentence, student, this sentence is false because 2 plus 2 is 4, not 3. So this is a false sentence. So, you know, what is the definition of preposition? A preposition is a declarative sentence which is either true or false. So this sentence is generally is false. Okay. So, but still it is a preposition. So preposition is a sentence which is either true or false. That means it has either the truth value or the false value, but at the same time it cannot both true or false. So further, the examples which are not the preposition are what is a beautiful day. So this is a exclamatory sentence, and you will not say this is a preposition. Shut the door. So this is a command type sentence. This is also not a preposition. Okay. What time is it? So this is a interrogative sentence. This is a interrogative sentence which is also not a preposition. So student, you should take care about these in this situation where your sentence is exclamatory, interrogative and the imperative in nature. Such sentences are not the preposition. So preposition, if a preposition is true, so we say that the truth value of the preposition is true, and this value is denoted by the capital letter T. Okay. So if a preposition is true, we say that its truth value of the preposition is true, and we will denote this it by the letter capital T. And if a preposition is false, we will say that the truth value of this preposition is false and denoted by the capital letter F. Okay. So next preposition, these are some examples. So now what is types of statement or the preposition? There are two types of preposition, generally primary statement or the primitive statement, which is a statement which does not contain any logical operators like connectivity, and, conjunction, disjunction, negation. Okay? So a statement which does not contain any connective like conjunction, disjunction, and the negation is called a atomic or the primary statement. What is compound statement? Compound, or sometimes you call molecular statement, is a sentence which is constructed by combining two or more statement using the connectivity. So whenever we will combine two or more sentences or the statement, then it is called a, with the help of the connectivities like conjunction, disjunction, it is called the compound statement. Okay, student? So there are five connectives or the logical operators: conjunction, disjunction, negation, conditional, and the biconditional connectivities. Okay. So conjunction is generally denoted by the letter this, by the symbol this, and the disjunction is denoted by the this, negation is denoted by this, and the conditional and the biconditional are denoted by the single arrow and the two-sided arrow. Okay. So next is conjunction, and what is conjunction, disjunction, and the negation. So conjunction of two preposition P and Q is a true when both the statement or the sentence are true, otherwise it is false. Okay? So conjunction of two preposition P and Q is true when both the preposition are true, otherwise their conjunction is false. Similarly, we will have the definition of disjunction. Disjunction of two preposition P and Q is false whenever both statement are false, otherwise it is true. Okay. And negation of a preposition P is denoted by negation of P and is read as it is not the case. So for example, my name is suppose Tanuj Kumar. So if I will write the negation of this sentence, so I am not a Tanuj Kumar. So this is a negation. So for example, P is a preposition, Ghaziabad is a city. So negation P is Ghaziabad is not a city. So if P is a preposition, then negation P is not that case. Ghaziabad is not a city. Okay. So these are the two tables of the conjunction, disjunction, and the negation. If P and Q are two statements, then their conjunction is denoted by P conjunction Q, and this is true. This is true only when both the statements are true. It is true only when both the statements are true, otherwise it is false. Similarly, disjunction, if both the statements are true, if any one of the statement is true, then it is true, or you will say that if both the statements are false, then it is false, otherwise it is true. So this is the truth table of the disjunction. And similarly, we have the truth table for the negation. If P is a statement which is either true or false, then negation P is, if P is true, then negation P is false, and if P is false, then negation P is true. So conditional and the biconditional preposition. the compound preposition if P then Q is called the conditional preposition, which is false if P is true and Q is false. It is false only in this case whenever our hypothesis is true and the conclusion is false. So otherwise it is true. So P is called the hypothesis and Q is called the conclusion. So it is generally denoted by P conditional Q. So it is false only whenever P is true and Q is false. Otherwise it is true. Similarly, we have the biconditional operator, and this is also a compound preposition, and it is denoted by P if and only if Q. P if and only if Q. It is called a biconditional statement, which is true whenever both P and Q have the same truth value. That means if both have, either both are the true or both are the false, then their biconditional is true. So let us see the truth table of conditional and the biconditional preposition. So here is the truth table of the conditional and biconditional truth tables. So conditional preposition is denoted by P conditional Q, and this is true false only when P is true and Q is false, it is false. Okay, otherwise it is true. Similarly, the biconditional, if P and Q are two statements, then biconditional is denoted by P biconditional Q, and this is true only in two cases: whenever both the statements are true and whenever both the statements are false. So then it is true, otherwise it is false. Okay, student? So what is a tautology? Tautology is a compound statement which is true for every assignment of the individual statement or the preposition. So for example, suppose we have a compound statement which is composed by the variable P1, P2, Pn. Suppose it is constructed with the help of n variable. Then for every assignment of truth values of these variable, if the truth values of the compound statement is true, then you will say that it is a tautology. So here in this example, you will see that if P is a statement, then it has two value. It has two value, either true or false, and their negation will have their opposite value, false and true. So if you take the disjunction of these two preposition, P disjunction negation P, then it is true. For every assignment it is, for every assignment of truth values for P and negation P, it is true. That means it is a tautology. So as I discussed in the previous slide, P disjunction negation P is true all the cases except whenever both are false, then it is false. So similarly, you will see that in the next example. In this next example, we will prove that, we will show that with the help of truth table, this preposition or this compound statement is a tautology. Okay. So here we have three variable. In this example, we have three variable P, Q, and R. So for three variable, student, we will have total 8 assignment. Totally we have 8 assignment. So for the variable P, you will have 4 assignment for the truth values and 4 assignment for the false value. Similarly, for the statement Q, you will have 2 values, 2 truth values and 2 false values, again 2 truth values and again 2 false values. Then for the third variable R, you will have the truth values true, false, true, false, true, false. So in this case, we have total 8 combination of the truth values, and now I will find out P conditional Q. As per the definition of conditional preposition, P conditional Q is false only where P is true and Q is false. So here student, you will see here, in this case when P is true, Q false, it is false. Similarly in this case when P is true, Q is false, it is also false. So only in these two cases the conditional statement P conditional Q is true, or sorry, false, otherwise it is true. Similarly student, we will find out Q conditional R. So it is false only in this case when Q true, R false, and here only in this case it is false, otherwise it is also here Q is true and R is false, so it is also false. So in these two cases it is false, otherwise Q conditional R is true. Now student, we will take the conjunction of these two. So by the definition of conjunction, if both the statements are true, then it is true, otherwise it is false. So student, here in this case you will get false, here you will get false, because one statement is false, here you will get false, here you will get false. So or in the remaining cases you will get true value. So only in these four cases you will get the false value, otherwise you will get the true value. Now suppose this statement or compound statement is denoted by the preposition or the letter A. Okay? Then we will calculate, student, P conditional R. So again we will calculate P conditional R. So whenever P is true and R is false, then it is false. So this case, second case, it is false in second case, it is also false in the fourth case. Okay? Only in these two cases it is also false, here and here. Okay, so now suppose this is a new, I say that this is a new preposition B. Now I will take, this is my preposition A and this is my preposition B. Now I will find out the A conditional B. So what is A conditional B? Conditional means if A is true, B is false, then it is false, otherwise remaining case it is true. So here you will see here T is true, T is true, here so there is no case whenever A is true and B is false. Okay, so conditional statement A conditional B is true in all the cases. So student, here you will see that all the values of A conditional B are true values. So that means it is a tautology. That means it is a tautology. Okay. So in the next slide, we will discuss about the contradiction. What is a contradiction? So contradiction is just opposite the tautology. So contradiction is also a compound statement which is false for every assignment of the individual statement. So if it is false for every assignment of the individual statement, then you will say that it is a contradiction. So in the first example you will see here P is my statement, first statement P, and the negation P is my second statement. So if P has the value true and false, then its negation will have the value false and true. And if you will find out their conjunction, so you will obtain false value. So therefore, for every assignment of the truth values for these variable P and negation P, their conjunction, which is a compound statement, is will have the false value. So this is a contradiction. This is a contradiction, or sometimes we will call it a fallacy. Okay. So similarly, in the second example, we will prove that this compound statement P conjunction negation Q conjunction of P conditional Q is a fallacy or a contradiction. So in this preposition, student, you will see here there are two statements only P and Q. So there are four assignment of the truth values for this statement. For P we have the truth values true, true, false, false, and for Q we have the truth values true, false, and true, false. So for these four statement, I will find out the truth values of the compound statement this. So first I will find out negation Q. So this is my Q. So what is my negation Q? True becomes false, false becomes true, true becomes false, and false becomes true. Then I will find out P conditional Q. So this is my P, this is my Q. So what is the definition of P conditional Q? P, whenever P is true, Q is false, then it is false. Otherwise it is true. So only in this case, in the second case, it is false. Otherwise it is true. Now I will take the conjunction of this and this, negation Q and P conditional Q. I will take the conjunction of these two. So what is the definition of conjunction? If both the statements are true, then it is true only. Otherwise it is false. So in the last cases you will see here, both the statements are true, so it is true, otherwise it is false. Okay, student? So then I will find out the conjunction of this compound statement with the P statement. Okay, so let us clear this slide. Okay, so now I will find out the conjunction of this and this. Conjunction means if both the statements are true, then it is true, otherwise it is false. So here, student, you will see here at least one of the statement either in P or in this preposition is false. So that means their conjunction will be a false, will have a false truth values. Okay, student. So here you will see that all the truth values of this compound statement are false. So you will see here, you will say that it is a contradiction. Okay. So next is equivalence of preposition. So student, whenever you will say that two preposition A and B are equivalent to each other. So suppose we have two preposition A and preposition B. So they are logically equivalent if they have the same truth values. They have the same truth values. Sorry, this is not the table. They will have the same truth values. Okay, or you will say that the biconditional of both the preposition is a tautology. So that is a very important thing here. If whenever you will say both two preposition are equivalent, whenever they have the same truth values, or you will say that their conditional A conditional B is a tautology, then you will say that A is equivalent to B. Okay. So let us take a simple example here. We will have this preposition compound statement negation of P disjunction Q, which is equivalent to negation of P conjunction negation of Q. Basically this is a De Morgan's law. So here we will prove both the statements are equivalent to each other. Okay. So in this preposition we have two variables P and Q. So there are total 4 assignment of the truth values. First we will calculate the disjunction of these P and Q. So disjunction is whenever both the statement are false, it is false, otherwise it is true. Okay. So this is my disjunction. Then I will take the negation of this. All the truth values become false values and false values becomes here truth values. Okay. So this is my left hand side of the preposition. So it will have the value false, false, false and true. Then I will find out the right hand side. So first I will calculate the negation P and the negation Q here. Okay. So what is my P here? I will take the negation of P. So true, true becomes false, false here, and false, false becomes true, true here. Okay. Similarly, I will find out the negation of Q here. Negation of Q here. Then I will take the conjunction of these two. So in conjunction, if both the statements are true, then it is true, otherwise it is false. So here, student, you will see this column and this column. Okay, both these columns have the same truth values. This column and this column will have the same truth values. So suppose this is my preposition A and this is my preposition B. So these two prepositions are equivalent to each other. Okay, student. So in this way you can easily show that, or you will also show that here. Suppose this is my A preposition. This is my A preposition and this is my B preposition. So if I take the conditional of these two prepositions, conditional means whenever conditional is false, whenever A is true and B is false. So there is no case here where A is true and B is false. So that means if you find out A conditional B here, what you will get here? You will get here in all the four cases you will get the, in all the four cases you will get the true value, because it is false only whenever A is true and B is false, but there is no case here. So that means it is a tautology. So if A conditional B is a tautology, that means A is equivalent to, A is logically, you will say that A is logically equivalent to B. Okay, student? So let us go in the next slide. So this is the law of duality. So how to calculate the law of duality of a compound statement. So dual of a compound statement that contain the logical operator conjunction, disjunction, conjunction, negation is the preposition that is obtained by replacing conjunction by disjunction, and disjunction, vice versa, conjunction by disjunction and disjunction by the conjunction. So conjunction by the disjunction. Okay. And if the preposition will have the variable t, which is a truth values of the variable, so it will be replaced by the variable false, and if it has the value false, then it will be replaced by the truth values false. So in any preposition you will replace your operators conjunction, disjunction, and the truth values variable true and false, then the resulted statement is called the dual of the original statement. So for example here, what is the dual of P disjunction negation of Q? So here you will replace this disjunction by the conjunction operator simply. You will replace this, so you will get here dual of this preposition. In the second case, you will replace your conjunction by the disjunction and disjunction by the conjunction and the truth values by the false value. So you will obtain the dual of this preposition. Okay, similarly in other cases you can easily find out the dual of the statement. Dual means you will replace their operators or the logical operator conjunction by disjunction or disjunction by the conjunction and true by the false and false by the true. Okay, student? So these are some law of algebra which is generally used to move a preposition or a compound statement with the help of this law without using truth table. So if you want to prove a statement or a preposition with the help of some law, so these laws are very important. So first law is the idempotent law. So here in this column we have right here the primal form, and the last column we have right the dual form. Okay. So what is the idempotent law? P disjunction P is equivalent to P. That means both these two statements are equivalent to each other. As I discussed, what do you mean by the equivalent? Equivalent means both the variable or both the preposition will have the same truth values. Okay. Similarly, in the dual, P conjunction P is a false value. Okay. Sorry, this is not a false. This is P. So disjunction of P with P and conjunction of P with P is P again. Identity law, disjunction of P with false value is P, and conjunction of P with true value is a P variable again. This is the dominant law. Disjunction of P and T is true value, and conjunction of P and false is a false value. Okay. Dual form. This is the dual form. This is the primal form. So dual can be easily obtained as I discussed in the previous slide. Conjunction is replaced by the disjunction is replaced by the conjunction. True is replaced by the false value. Okay. So then we have the complement law. Disjunction of P with negation P is true, and this is your dual form. Conjunction of P with negation P is false value. Then we have the commutative law. P disjunction Q, Q disjunction P, both are equivalent. Similarly, in case of conjunction, P conjunction Q and Q conjunction P are also equivalent to each other. This is my associative law. Associative law means order of the preposition or compound statement doesn't matter here. So if you calculate P disjunction Q first and then take the disjunction with R, or if you calculate Q with R, disjunction Q with R and then take the disjunction with P, in both the cases you will obtain the same truth values. Okay, so this is the dual statement, dual form. Distributive law. So here we have three variable P, Q, R. So here we will distribute the variable P. Conjunction is distributed over disjunction, and this is P conjunction Q, disjunction P conjunction R. Okay, student. So this is my distributive law. Then we have absorption's law, and then we have the De Morgan's law. So this law is very important, student, and you can easily prove this law with the help of by making a truth table. And further we will use this law to prove a statement, compound statement, to prove the identity of the compound statement. So let us move on the next slide. So these are some equivalence involving the conditional operator. So these are also important. So student, you should remember these equivalences involving the conditional operator here. So this is equivalent to this is equivalent to, and you can easily verify by making a truth table. So both the statement or the prepositions are true. Then student, we have the equivalence involving biconditional operators. Similarly, we have these two. If a preposition involving the biconditional operator, then we will say that this is equivalent to this, and you can easily prove these biconditional equivalences by conditional operator with the help of making the truth table. Okay, student, let us see this example, and we will prove this preposition. We will show that this preposition is equivalent to this preposition. Okay, without using truth table, we prove it by using some top algebra. So here, taking the left hand side, what is my left hand side here? P conditional Q conditional P. Now first I will open the compound statement which is in the parenthesis. So Q conditional P, as from the previous rules, Q conditional P is negation of Q disjunction P. Okay, again I will apply the definition of conditional operator. This is negation of P disjunction negation of Q disjunction P. Clear? So here, because we know that P conjunction P conditional Q is logically equivalent to negation of P disjunction Q. So by using this rule, I apply this rule here. Now apply the commutative law. So this is negation P. This is negation P, disjunction P, disjunction negation of Q, and then apply the associative law, combine this and this, negation of P, disjunction P, I combine these two and separate it, negation of Q. So by associative law, here I will apply the associative law, and here I apply the commutative law. Okay, so now student, negation of P disjunction P is my truth values, it is true value, and if you take the disjunction of true with negation Q, it is also a true value. So from the left hand side we obtain the true value. Similarly student, we will solve the right hand side. If from the right hand side we get true value, then it is both the statement are the equivalent. So let us see from the right hand side. So in the right hand side we have negation of P conditional Q. So this is our right hand side. Okay. So first I will open, this is negation of P conditional, the parenthesis. So it is negation of P disjunction negation of Q. Okay. Now I apply the definition of conditional operator. So negation of negation P disjunction negation of P disjunction Q. Okay. So negation of negation P becomes P, and this is disjunction of negation P negation Q. Now apply the associative law. I will combine P and negation P. So P and negation P becomes our true value. It becomes our true value, and true value and disjunction with Q will get a overlap. So here student, you will see, if I apply the law of algebra, from both the side we will get the true value. So both these two statements are equivalent to each other because both are equivalent to a total. Both are the tautology. So let us move on the next slide. So student, you can try this example yourself. So with the help by applying the law of algebra and the equivalence involving the conditional and the biconditional statement, you can easily prove this question. Okay. Now moving on the next slide. Tautology implication. What do you mean by the tautological implication? A compound preposition A is said to be tautologically implied to the compound preposition B if B is true whenever A is true. That means if A conditional B is a tautology, then you will say that A implies to B. A implies to B. So simply you will see this in this example. P implies to P disjunction Q. You can easily prove this. So taking here in this first example, we have two variables P and Q, and for these two variables we have the four assignment values, truth values. And now I will calculate the P disjunction Q. This is my P disjunction Q, and take the conditional with P. So this is my P. So here we will have all the truth values here. Okay student. So whenever A conditional B is a tautology, that means A implies to B. So if A, this and this P conditional P disjunction Q is a tautology, then you will say that P implies to P disjunction Q. Okay. That is the meaning of tautological implication. That means A implies to B if A conditional B is a tautology. Okay. So similarly you can do in the next example. Moving on the next slide. Thank you. So in this unit, student, we have covered all the topics related to the mathematical logic. So thank you student. In the next lecture we will discuss other portion of the course.